Question 3. Here we are asked to find where the gradient is 1. Gradient should trigger that you differentiate. I've rearranged the equation here to put the x squared at the front. Now differentiate by multiplying by the power and reducing the power by 1. The number will disappear. It says that the gradient is 1. So we replace the 1 with the f dash x. Then you solve that, bring the 3 to the other side to make negative 2, divide by negative 2, and you get your answer. The answer, or the question says, find the coordinates. That's not a coordinate, so we put 1 into the top equation and work out what that is, and we find that it's 4. So the coordinate is the point 1, 4. It's achieved. For the next one, we want the profit to be increasing. So we need to differentiate that. This here is a negative x squared, and so we can see that the profit is increasing in the red part up to the turning point. So when we differentiate it, which I've done there, multiplied by the power, reduce the power by 1, the number disappears. We make it equal 0 to find where the top of that graph is. Put the 0.04x, negative 0.04x to the left, it becomes positive. Divide by 0.04 and you get 7,500. So the profit is increasing up to the point 7,500. At 7,500 the profit is at its maximum. I'll give you excellence if you can do that. For this question, we've got an acceleration equation, so we're asked how far we need the distance. To get the distance, first of all you have to do the velocity. Copy out the acceleration equation, then and put a t beside the 2. You add 1 to the power, divide by the new power, and you add a constant. So in the acceleration equation, the 2 was actually 2t to the power of 0. So it becomes 2t to the power of 1. You don't need to put the 1 there. Tidy that up a bit by putting that as negative 1/10. The c is actually 0. When you think about it, it's when time in seconds after he releases this balloon. So both the distance and the velocity constants are 0. Because when he's holding the balloon it's not moving and the distance is 0 from his hand. We want how far, so we want the distance equation. We're going to have to anti-differentiate it again. Copy out your velocity equation, then add 1 to the power divided by the new power. Do the same for the t squared, make it t3 divided by 3 at a constant. Tidy that up a bit to make it negative 130 over t cubed. We know that the constant is 0 because that's when it's released from his hand. We want after 6 seconds how far it had travelled, so put 6 for t, and you just do 6 squared minus 130 times 6 cubed, 28.8 metres. That's relational thinking, merit. For this question, you're given the gradient. That means you're given y dash. If you're given y dash, you're going to probably have to find out what y is, so you're going to have to anti-differentiate. That's the differentiated equation. So to anti-differentiate it, you copy it out, add 1 to the power, divide by the new power, do the same for the x, and make an x appear on the 3, add your constant. If you tidy that up with the 2 over 2 to make 1. Now you're told the coordinate of the minimum point is negative 1. The minimum is where the differentiated equation equals 0. So we go 0 equals x squared plus 2x minus 3. Factorize it, and you'll find that x could equal 1 or negative 3. Now the equation there is a cubic one. And so the minimum point is at 1 and the maximum point is at negative 3. You can see that by the graph. Negative 3 comes along the x-axis before you get to 1. what we do is we put 1, negative 1 into the equation for y. That will help us work out our constant. Change side, change sign, and you find the constant is 2/3. Now I'm going to write that equation, the second blue equation, bluish purple equation. I'm going to put the 2/3 there, and now we are going to work out what the maximum point is. The question asks for the coordinates of the maximum point, so I'm going to put -3 into there, and that will give me -9 plus 9 plus 9 plus 2/3. That's 9 2/3. So the maximum point is -3 and 9 2/3. This one here is quite easy if you understand a few things. Look at the gradient. I'm going to write the gradients on the actual graph there. So the gradient at -4 is -2. The gradient there is 0, 2, 2. The next point the gradient is 2. And there it's 2. We're told that at h3 it equals 7. So at 3 we put the point 3, 7, and we give it a gradient of 2 right down to the y-axis. There we go. We need a hollow circle at the y-axis because it's a point that's not differentiable. Now, we've got the gradient there has to be at 0, so we put a dot on or a cross on 0. Below this one here it has to be at 2, and below this one here it has to be at -2. And so join those up, and there is our equation. It will give you excellence for that part.